All right, folks, here is a video on week 19 Wednesday FTC number 2, part 2, number 3, 4, 7, 9, 18, 19. Okay, so let's look at, let's see if I can pull up the unit circle here. Okay, so now number 3, we basically want the area of the shaded region, which is the area of the rectangle minus the white zone, which leaves us with the shaded, which is what we want. So the area rectangle is going to be 2 times pi. Okay. All right, 2 pi. And the area of the white zone right here, okay, is going to be the integral of from 0 to pi, lower bound, upper bound, of 1 plus cosine x. Okay? And so, since it's not a perfect shape, we got to take the antiderivative, plug in upper bound, lower bound, subtract it from each other. Okay? And then you end up getting a clean pi, which is right here. Okay? And you can, for sine of pi, sine of 0, you should know that. Okay, but here's a unit circle. You can press pause to look at it. Okay, I think I said sine of 0 and sine of pi, which is going to be right over here and here. Let me just double check. Yep, sine of pi, sine of 0. Okay, now here, for number 4, we're going to find the area of this shaded region. So basically, we are going to find the area under the curve from pi to 5/6 or 5 pi over 6, subtract the white zone, and that's going to give us the leftover blue zone. Okay? So, I'm going to do the integral underneath this curve from pi over 6 to 5 pi over 6 of sine of x. Okay? And the since it's not a perfect shape, we'll use the antiderivative. Antiderivative of sine of x is negative cosine of x. Plug in 5 pi over 6, and 5 pi over 6, pi over 6, and you subtract it and you get these. So let's just walk through the unit circle here. Okay, so cosine of 5 pi over 6 is going to be negative root 3 over 2. Okay, and there's a pre-existing negative over here. Okay, because of that. Okay, cosine of pi over 6, okay, is going to be root 3 over 2, okay, and because there's a pre-existing negative here, we got the negative there, okay, and then 2 negatives make a positive, okay, and then 2 negatives is going to make a positive, so this is going to end up being 2 root 3 on top over 2 on bottom. The 2's cancel, you're left with root 3. Okay? And the area of the rectangle here, okay? So root 3 is the area underneath the curve, this zigzag red zone. The area of the rectangle, well, the base is going to be 5 pi over 6 minus pi over 6 right here. And the height, we're going to plug in pi over 6 into sine of x, because the height of the rectangle happens to be this point on the blue curve. Okay, we could also plug in 5 pi over 6. Let's just plug in pi over 6 because that seems easier. Okay. Pink. When we plug in pi over 6 into sine of x, I get root 3 over 2. Okay. So this ends up being root 3. No, hold up. Oh, sorry, sine of pi over 6. I did cosine. Okay. So that 1 over 2. Okay, that's where they got 1 over 2. You simplify it, you get pi over 3. And we do root 3 minus pi over 3 because we're doing the red zigzag zone minus the rectangle, which is pi over 3. So the red zigzag zone is root 3. The white rectangle is pi over 3. Okay? Let's go to 7. Okay. 7, okay, first of all, this is kind of unnecessary. That 0 is unnecessary, and this is unnecessary. Okay, so that may have been what confused people. So this got copied down, okay? And then we take the derivative because that's what it's asking for, okay, the derivative. So we take the derivative of this, the derivative, antiderivative. This can, and what we're going to do is we're going to flip the bounds, okay? Flip the bounds, flip the signs, and I'm going to get ln 1 plus x squared, okay, 1 plus t squared, sorry, okay, dt, okay, like that. The x gets dropped in, okay, because there's the ddx here. Boom. Boom. Because there's a ddx there, this cancels, okay? This cancels with the antiderivative. X gets dropped in for the t, and then we have a negative there, and that's why we get this. So that's this, what they wrote over here is kind of extraneous, okay? What I crossed off. That's number 7. Let's go to number 9, okay? Number 9 is basically the antiderivative. When you do the antiderivative of this, you end up getting this. We've done that quite a few times. That's based off of what I usually put on the screen for test hints. Let's see if I can quickly find it. Boom. Here. Okay. And it's basically right over. Okay. It's right over here. There we go. So we're going to be using this one right here, okay? We're going to be using that one right there, okay? So we can verify the antiderivative is correct by taking the derivative of this. The derivative of this, based off of this, is going to be 3 to the power of x ln 3 like that, okay? And then the ln 3 is going to cancel with the ln 3 here, and you're left with the 3x right here. So we verify that the antiderivative is true by taking the derivative of the antiderivative, okay? And we take the derivative of the 3 to the x, 3 to the power x that's in the pink in the background over here, okay? Whoops. That's in the background over here. You end up getting this red, and the ln 3's cancel, and you're left with the 3 to the power x, which matches with the original here. Okay, so we know it works, okay? Now, I plug in, now you basically just plug in the upper bound, plug in the lower bound, and yeah, that's basically it, okay? Plug in upper bound, subtract, plug in the lower bound. But let's see if I am, okay, yeah. So there's a 1 over ln 3 here, okay? When you plug in -1 in for x, you get 3 to the power -1, which is 1/3. So you get 1. So you basically, when you plug in the upper bound, you get this with plugging in -1 to x and then 1/3. Okay. And then when you plug in 2, okay, here, you end up getting 3 squared, which is 9, and then the 1 over ln 3 in front of it. And what they did is just GCF the 1 over ln 3. Okay? And let's see how they simplified it over here. Oh, basically, 9 can be rewritten as 3 over 27. 1 minus 27 is -26. Okay, and then and then again, basically this becomes -26 over 3. And then you multiply gray with gray and you get that. Okay? Let's talk about number 18. Okay? Now let's use the calculator to determine the following. Okay, so let's look right here. Okay. Now, we're going to go math. Okay, this is number 18. Let me just make sure I'm doing the right problem. Yep, 18. So we're going to go math, integral, -0.8, 0.8, here, I'm going to go 2 x to the power of 4 minus 1, close that parentheses, divided by x, let me do another parentheses, x to the power of 4, okay, minus 1, close that parentheses, and put a dx over here, and press enter, and I get 1.427 when rounded. Okay, and that's the answer here. Okay? Now, the average value of a function, okay, if you want to review it, you go to, let's see, excuse me. Here you go, week 16, Monday, December 2nd, right here. Okay? And this is basically a formula. Okay? This is basically a formula. So, the function you just put right here, lower upper bound, okay, put it right there, and you literally do 1, which is a constant, over upper bound minus lower bound. So upper bound right here minus lower bound right here is that. And you just plug that into your calculator. Okay. Let's see. Let me try to show you over here. Math, integral, okay, -1, 1, square root cosine of x. Whoops. And then dx. And then I'm going to multiply that by 1 over 2 from here, which is basically 1.5, which is 0.5. And I get 0.914 when rounding. Okay? So I treat this, I've entered this in the calculator, and then just multiply it by 1/2, which is 0.5. Okay? Thanks for tuning in, folks.